Okay, so today we are going to look at two other types of classifications of chemical reactions, single and double displacement reactions. So previously we did synthesis, where two elements combine to form one compound, and we did decomposition, where a compound breaks into its elements. But a single displacement reaction is a reaction where you have a single element and a compound. And what ends up happening is the single element will actually displace one of the elements in the compound. So it's going to break up the group. So here we have carbon and copper 1 oxide, and it produces carbon dioxide and copper. So what's going to happen is here's our single element of carbon, and it's going to come in and it's going to break up this group here. So it's going to displace copper to be by itself, and it's going to bond with the oxygen. Okay, so one single element is displaced. So that is why it's called a single displacement reaction. Your general formula for a single displacement reaction, a single element, A, plus a compound made up of B and C. A, right, displaces B, so you get AC as a compound and B as a single element. Now, with single displacement reactions, they tend to occur when A is a metal. It's not necessarily always the case, but generally these occur when your element that is by itself is a metal. So because of this, single displacement reactions are used a lot in society in mining. Okay, we know metals rarely occur as pure elements. They're actually combinations of other elements, and they form ore. So what actually happens in mining is what we call smelting. So if we look at, for example, nickel, we mine nickel sulfide, and it undergoes a couple reactions, one of them being a single displacement reaction, to actually extract the pure nickel from the nickel sulfide. So again, I said it's a two-step process. The first step being the nickel sulfide, the ore is mined, and it is combined. We break that up with a decomposition reaction to form nickel oxide and sulfur dioxide. And then what happens is we take the nickel oxide, and it undergoes a single displacement reaction with carbon, and the carbon comes in and displaces the nickel, so now we have pure nickel, and it produces carbon monoxide. So one thing to note from mining is that it does produce a lot of noxious gases. We have sulfur dioxides, we have carbon monoxide, and both of these gases we'll see when we get to our unit on climate change have an effect on climate change. So is an example of a single displacement reaction. Now, the other type of reaction I want to talk about is a double displacement. So with single displacement reaction, we had a single element kicking out another element. For double displacement, what actually happens is as one element displaces one element in a compound, that element that is displaced actually replaces the initial one. So what initially happens, or basically happens, is the two elements in the different compounds trade places. So if we look at the general pattern for that, we'd have a compound AB, and we'd have a compound C and D. So we're starting with two compounds here, and A actually comes in and displaces C, and C would come back and bond with B. So we get A bonded to D, and C bonded to B. Okay, so we have two compounds where if we think of these, the first two elements in both compounds actually switch locations. Now, when we're dealing with double displacement reactions, generally these two compounds tend to be ionic compounds. So when we're talking about the element that switches, it's generally the metal. So here we have an example. Silver nitrate and sodium chloride produce silver chloride and sodium nitrate. So what's going to happen here is the silver will come and displace the sodium to form silver chloride, and the sodium goes back and bonds with the nitrate to form sodium nitrate. So again, both of these metals have changed places. So Not all the time, but very often it occurs between two ionic compounds for double displacement reactions. So that's basically it. Single displacement, you have an element and a compound, and the element replaces a metal in the compound. For double displacement, you have two compounds and the metals change places.